Chapter 8, Section 5, Day 2, Part 2. Just a little review from yesterday. You have a couple trinomials that I want you to factor. So actually this is a good place to pause really quickly. Try these on your own just to make sure, and then come on back to make sure that you have the same answers as I do. Okay, remember that we're looking for something that adds to be the C value, or multiplies to be the C value, but adds to be the B value. Because I don't have a coefficient in front of the g squared, I know I just need a g in each, and so this one is g plus 2 times g minus 7. Okay, over here I need a p in each, and I need to multiply to be 12, but add to be 8. So I have a 6, a positive 6, and a positive 2. Okay, down here I have a d for each, needs to multiply to be 45, but add to be negative 18, so I have a minus 3 and a minus 15. All right, today we're going to do a couple word problems and then add in another variable, but we're going to start with these word problems. The area of a rectangle is given by the trinomial x squared minus 2x minus 35. What are the possible dimensions of the rectangle? And use factoring. Okay, so remember that the area of a rectangle is just length times width, but they're telling us that the area is x squared minus 2x minus 35. So they want to know what two things multiplied together will give us x squared minus 2x minus 35. And so that's just the factoring that we've been doing, only they gave it to us in a word problem. All right, so I know that I need an x in each of these, and I need a number that multiplies to be negative 35, but adds to be negative 2. Okay, well, the factors of 35 are 1 and 35, 5 and 7, and that's probably it. So I think 7 and 5 are ones that we can make add up to a negative 2 if I have a negative 7 and a positive 5. All right. The area of a rectangle is given by the trinomial n squared minus 3n minus 28. What are the possible dimensions? Use factoring. Okay, if you want to try this one on your own, here's a good place to pause. If not, we are looking for a number that multiplies to be negative 28 but adds to be negative 3. My factors of 28 are 1 and 28, 2 and 14, 4 and 7, and that is it. So the only ones that I can get to add to a negative 3 would be 4 and 7, which means I'm going to need a positive 4 and a negative 7. Okay, here's where we get something new. Now we're factoring also a trinomial, but now I have two variables. I have x's and I have y's. Okay, if I remember, what I'm really doing is unfoiling this. So I'm kind of working backwards. And if you remember what FOIL stood for, it was first, outside, inside, last. This is what's going to give us our first number, or the answer when we multiply our first digits. This is going to give us the combination of our outside and our inside. Remember, we end up adding those together. And then this is what gives us our last. Okay, so when I am factoring this first number has to be whatever it's going to make, or whatever it's going to take to make the x squared. So there's where I have my x times x. Then I still need a number that will multiply to be negative 55 and add to be 6. But this time, because my last digit has to be y to the second power, they're each going to have a y in them. And we'll FOIL this afterwards just to prove our answer. Okay, so what could multiply to be 55 and add to be 6? Okay, well, multiples of 55, or factors of 55 is 1 times 55, 5 times 11, and that might be it. I can make 5 and 11 equal 6 if I have a positive 11y and a negative 5y. Okay, so this is your final answer, but we're actually going to use FOIL to just prove that with another color here. So if I multiply my first, x times x is x to the second power. Outside gives me 11, positive 11xy. Inside gives me negative 5 times x times y. And last gives me a negative 55y to the second power. Then if I combine these like terms, I'll have x squared plus 6xy minus 55y to the second power, which is exactly what we started with, so we know that this is the right answer. All right, here's another one, same idea. I have two different variables, so I know that I'm starting with m's and ending with n's, so that I can get both the m squareds and the n squareds. Now I need numbers that will multiply to be negative 27, but add to be positive 6. My factors of 27 are 1 and 27, 3 and 9. That might be it. So I think I'm going to need 3 and 9 since I can make those equal 6 if I use a positive 9n and a negative 3n. All right, because we don't have partners for this, we're just going to work through some of these factor forms. These are mostly from day 1. Okay, so I need a number that will multiply to be 20, but add to be 9. Well, multiples of factors of 20, I have lots. I have 1 times 20, 2 times 10, 4 times 5, and then backwards. So it looks like 4 and 5 will make 9, and everything is positive, so we'll be plus 5 and plus 4. Okay, down here I have an x and an x, and I need to multiply to be 8, but add to be negative 6. This time I'm going to need both negative 2 and a negative 4. Okay, I'm going to need 2 x's, multiply to be negative 18, but add to be negative 3. Okay, well, factors of 18, 1 and 18, 2 and 9, 3 and 6. 3 and 6 I can get to equal a negative 3 if I have a positive 3 and a negative 6. Okay, word problem. The area of a picture frame is given by the trinomial x squared plus 6x minus 16. The length of the frame is x plus 8. What is the width? Okay, remember area is equal to length times width, and they already gave me the length. So for my x squared plus 6x minus 16, for factoring, they've already given us x plus 8. So I need to figure out what else I need. Something that multiplies to be negative 16 but adds to be 6, and I already have an 8. That means I need a negative 2. So my width is actually x minus 2 for this picture frame. All right, last but not least, factored form of x squared minus 1xy minus 6y to the second power. Two variables, both to the second power, so I know my x's go first, and I need y's at the end. I need a number that multiplies to be negative 6 but adds to be negative 1. Okay, and to add or multiply to be 6, we have 1 times 6 and 2 times 3. So I think we're going to need this 2 times 3. That would mean I need a positive 2 and a negative 3. All right, that's the end of 8.5. Your homework is on page 503, numbers 14 through 19, 24 through 40, 44 through 46, and the lesson quiz.